Um, hello and welcome everyone to whoever is listening to this particular podcast on YouTube, Spotify, Apple, Google, or any other platforms. I am Shah. I'm a PhD student at Arizona State University, and I invite machine learning engineers, researchers, entrepreneurs to talk more about their current work, their journey, and how to get started with it, and wonderful insights they have along their journey. And for this particular podcast, I have with me Aarti Bagul. Aarti Bagul is a machine learning engineer at Snorkel AI. Prior to that, she worked closely with Andrew Yang in various capacities at AI Fund, helping build machine learning companies from scratch internally, as well as investing in machine learning companies and as a machine learning engineer at his startup Landing AI, and also head TA for his deep learning class at Stanford, the CS230, which by the way I have I really like that course, so we'll talk about that later if we get the chance.
Yeah.
And she also worked at his research lab at Stanford. She graduated with a master's in computer science from Stanford University and with a bachelor's in computer science and computer engineering from New York University, where she get to work with David Sontag's lab on applications of machine learning to clinical medicine, and also at Microsoft Research, she was a research intern for John Langford, where she contributed to Vowpal Wabbit as an open source project. So, Aarti, welcome to this podcast.
Yeah, no, thank you for having me. Excited to be here.
All right. So, can you tell us a bit about your journey into ML? How did you get into it, and what did something interest you about ML that really motivated you to pursue it as a research or any other capacity?
Yeah, I can take it from the beginning. So I'm originally from India. I was born and raised there. And then I came to NYU for my undergrad and started doing computer science. And I had never really coded before freshman year. So already it was all very new. And then sophomore year, I was still trying to figure out internships, what I wanted to do. And I was told that working with professors is like a good way to, get your hands dirty, try to, learn stuff. So I reached out to a bunch of professors, David being one of them. So I almost ended up in ML systems working for a different professor, but then ended up choosing David's lab. But really grateful for David for taking a chance on me. So ended up doing like database work for him, just like started working, was helping transfer some like clinical record databases into a different format. His lab, he's now at MIT, does machine learning for healthcare. And I come from a family of doctors. My mom's a doctor. I almost went to med school in India. And it was just like, I mean, CS as like a major already was new to me, but the fact that you could predict who was going to get a certain disease from their clinical records was just so amazing, fascinating, and mind blowing as like a concept. I was like, wow, computers can do that. And so that really, just being in that lab, being exposed to that environment, and I was like, wow, everybody knows so much more. I'm barely getting the hang of CS, and now there's this whole new world out there. But it was very exciting, and that kind of prompted me to work in David's lab. I ended up working in his lab for 2 years after, and then just continued. And I was very into machine learning for healthcare for a while. So even Andrew's lab at Stanford, they do machine learning for medical imaging. So kind of different in terms of what they do, but still in healthcare. Um, so really, and then just being in this field, I think it's super exciting how fast it's growing, all the potential impact it could have. And having gotten various experiences just motivated me to stick around.
Right. Yeah, that's a nice journey. Like you are much more inspired from the applications of machine learning, and hence the interest and the top-down approach into the machine learning domain. So yeah,
Yeah,
that's a nice way. And
definitely.
yeah, and as a machine learning engineer currently at you recently joined Snorkel AI, which by the way, congratulations. And like, can you tell more about like what does that role entail for you as a machine learning engineer at such a place?
Sure. Yeah. So I joined Snorkel 2.5 months ago, so still pretty new. Already feels like quite a while. Really enjoying it. I can give a brief spiel on Snorkel if that's interesting, and then I can go more into sort of my role there.
Yes,
Um,
please.
Yeah, so Snorkel is a startup in the Bay Area. It was started as a research project at Stanford, centered around data labeling. So you kind of see this theme. I'm really interested in sort of like practical AI. How do we make stuff, actually achievable in the real world? And for machine learning models, a huge bottleneck is training data. And so the founders of Snorkel, PhD students, as well as Chris Ray, who's a board member, who's a professor at Stanford, saw this very early on and started tackling it in an interesting way where for supervised learning, you kind of people just have to go through and label like tens of hundreds of thousands of examples, and it's very tedious, very expensive. And so they were like, there has to be a better way. So Snorkel started as a project to really tackle this bottleneck of training data. along the lens of programmatic labeling. So it's called weak supervision. You can look it up, weak supervision Snorkel, or it's just a general term used in the industry as well. And what that means is you're labeling your data in a very noisy way. So you can specify rules of thumbs or heuristics to label your data instead of explicitly labeling a data point. So as an example, let's say you want to label a document as some type, and you can specify heuristic, like if this word is in the document, then label it as such. And that allows you to label large amounts of your data very quickly. It allows you to iterate on, like, let's say your classes change or you have new data coming in, that's efficient. It also just lets your subject matter experts give their expertise in a more efficient way. Like I worked in clinical settings, and you're asking doctors to sit there and explicitly label each data point. It's really expensive, and doctors have a lot going on. So you can kind of, instead of, Snorkel has been used for image work as well. So instead of them being like, this is cancer, this is not cancer, you can say, well, I generally look for a tumor this big with these kind of edges. So it allows you to consolidate sort of doctor knowledge in a more efficient way as well. So Snorkel started off as this programmatic labeling, weak supervision approach for getting labeled data. And then what the founders realized is this really is a whole different way of iterating and building machine learning applications. Now, instead of like spending a lot of time training your model, which really is push button at this point, or can be, very commodity, you're spending a lot of time iterating on your what we call labeling functions, which is like, are they accurate, refining them, writing more of them. And because of this like super different iterative cycle and a whole different way of building ML applications, they built out the whole platform, which we call Snorkel Flow, which is our commercial product. So Snorkel itself actually is an open source project that you can check out, but Snorkel Flow is a whole end-to-end machine learning application, which has at its core this idea of programmatic labeling. That was a super long, not really an elevator pitch for Snorkel, but I can now go into sort of what my role is there, unless you have more questions about Snorkel.
No, definitely. I mean, definitely. I personally knew Snorkel AI a lot, so I'm not sure about the people who are listening to this, but definitely, I have been inspired a few bits of Snorkel AIs, because even when I started my research projects, what happened was we are doing with this large images, and we definitely don't want the whole input as the deep learning model input to over there, so we use weak supervised labeling over there. So we have these and few of my other lab members precisely. I haven't have a full published paper yet, but of course I have been dabbling around these things. And when you Google these things, Snorkel AI definitely feels on the first 10 pages of Google. So definitely I knew a bit about Snorkel AI, but yeah, feel free to continue about your role. Yeah, sorry about that.
Yeah, no, that makes sense. I unfortunately was not very familiar with weak supervision and sort of what was state of art there. So I guess if you look up weak supervision, Snorkel shows up. But ever since I joined, I was like, wait, this is just a fundamentally better way to do things. And why are more people not aware of it? And maybe they are, and I just wasn't. But definitely very cool in terms of what they do.
I think the reason weak supervision is not so popular, it's only if you are dabbling with clinical applications or healthcare applications, where you have these images which are highly rich, and only those things make sense. If you're dealing with natural images, it's better to not look at those, because it's easy. First of all, it's easy to label. I mean, I won't say easy, but in the last few years, algorithms have become very efficient at labeling those things, versus it still remains a challenge for medical images to label them, and we are still dependent on experts or humans. Yeah.
Yeah, that makes sense. I guess for Snorkel, the company itself, we've decided to focus mostly on text data and documents. So either extracting stuff from documents or text classification, just as like something we start with. But I can definitely see your point about the medical images. Definitely, I think three problems our customers face, which is why they come to us, is and then I can finally move on to my role and what I do. So I'll take up the suspense there.
That's fine. Yeah.
But for weak supervision, I think, or for Snorkel as a use case in programmatic labeling, the reason it's great for some of our customers is, first, is privacy concerns. They can't just send their data out to be labeled either by Mechanical Turk or other companies that do data labeling. So they have to have their own internal people label data, and then Snorkel is just a more efficient way to do it. The second thing is, maybe your data, there's a lot of data flowing in, and training data is not just like a one-stop, like I paid $1 million, which yes, if people pay an absurd amount of money to get training data, it's not just like a one-stop thing. You have to keep labeling data, and maybe your classes change, and then you have to pay people again. So labeling functions is just a faster way to, you just write them once and then you can continue doing that. And then the last thing could also be sort of like interpretability. A lot of sort of biases in in machine learning models, not all do come from training data, and you don't know how your data is labeled, and it's hard to track that. And so labeling functions can be a good proxy to see like, why did my data set get these labels and how did they end up this way? So that's another benefit of Snorkel that people really like. And then finally, what I do at Snorkel. So I am a machine learning engineer at Snorkel. Machine learning engineer really is a different role at different companies. Could go on forever about that too. But specifically at Snorkel, what that means is, so we are a platform for machine learning engineers, which means that we're sort of dog fooding our own product, which is like kind of using our own product because we're supporting our current customers and helping set up their use cases on our platform. So I kind of would break my work down into sort of three buckets. The first one's like machine learning engineering work, which is work with the customer facing to help them use Snorkel Flow. It looks slightly different than a traditional machine learning engineer role because we spend way more time sort of in the, iterating on labeling functions instead of like in Snorkel, you can just press a button or select a model and then it trains it for you. So really a lot of the thing is like, how do we write these labeling functions? We also deploy the models and stuff, but we have other teams to take care of that. So there's the customer facing aspect, and then we're still actively building the platform as like a general purpose platform. So there's thoughts around like, if we bring on a customer, are there certain product decisions that we want to make and incorporate back into the platform? So a bit of like product thinking there in terms of what we should build, how we should update the platform. And then software engineering, which is, should I build it as like a quick prototype to test it out or hand it over to the backend team so they can actually incorporate it? So I'd say like product, software engineering, and machine learning engineering kind of mix there.
Right. Yeah, that's really interesting. And one of the few things that I personally feel I lack, and over the time I haven't learned, and I don't know, PhD would be the best place, even in the next few years I'll be learning, is talking about reliability. Like if you are building these things, definitely they are still a research paper at max that you can target at a big name conference. So I want to learn from you. You have worked at least two places that I would say one of the few of the best places that you can find in academia. That is David's lab and Andrew's lab. That you get to work in an academic sense, that you have a different set of goals while you are working on a project. It's not always the best on robust process that you are targeting at, but you are trying to make much more of a pushing the boundaries of research, versus you recently started, like you said, couple of months back at Snorkel, where everything is about robustness, like you said, like generalized version of this particular software that people can use. So what kind of things that you have noticed in terms of you as a person who is working in these settings of research versus production level quality kind of projects, and what are the things that people might not know? And feel free to take it from a student's perspective, like what things did not I know before I joined a place that could have such kind of reliability priorities.
Yeah, no, that's a really good question. For a while, anytime like, I've been meaning to start a blog, like I think most people, and just haven't, but I always thought that the first one should be like what no one tells you about being a machine learning engineer. Because even as like someone who, I mean, I started working in ML in like 2015 or something of that sort. And I didn't start my first like real machine learning engineering job until like I started working at Andrew's company. And I was like, wow, I thought I knew ML and things, but there's so much more to building like an ML product that nobody tells you, or just being a machine learning engineer. And I've spoken to a bunch of my friends who've also made the transition from research to like production ML. And really, I think the primary thing you learn, and there's like a very popular like Google paper which has this like diagram of like these boxes in an ML system, and like the model is like a very small part of it, and you will see that in every slide. But it's really true. Like I think in research, like your whole life is like, here's a data set. How can I improve on this data set? And the data set's kind of fixed. And then when you go into production level environment, or sort of like real life, and it goes back to sort of what Snorkel's value prop is. The first step is like, where do I get data? How do I collect data? And it's like, how do I label data? I don't know. And then it's like, okay, you can train the model. Training the model is really the easy part, because you're not really trying to solve research questions or problems there in most cases. So you can just use something off the shelf. You can just use something that other people have, built on GitHub or something. And then it's like, okay, well, now how do I make my model reliable? I deployed it, but let's say at Andrew's company, which was my first machine learning engineering job, we were doing defect detection. So it's like, given a part, mention that like what type of defect does it have, and blah, blah. Another problem there is if it's any good of a manufacturing company, they don't have that many defective samples. Otherwise, it wouldn't be in business. And so it's like, first of all, like, how do you collect? Like, there's such an imbalance in the data. How do you deal with that? What if a new type of defect pops up? How do you deal with that? Lighting conditions change on the belt, and then the model goes haywire. Like, how do you deal with that? So going back to these like changing conditions and monitoring. So I really think that more of the focus is around like the data collection, labeling, gathering, processing part, and the deployment, monitoring, blah, blah, blah part. And then the model training is really like, I can do that. But even there, it's like, I think in research, maybe you're writing shitty code, you're the only person who's running your code. But in a production or a company environment, it's like, well, how do people collaborate in machine learning teams? Like, you can't just train parts of the model. It's like, am I training, like, how do you distribute work in a startup? That was one thing I had to think about. The other thing was like, how do you make it reproducible? A lot of things are changing every day. How can I make sure I'll get an experiment result that I got a while back with all of this stuff changing? So it's like experiment tracking, that kind of thing. Yeah, so in general, I think looks very different. And this coming from like, I think I worked in fairly applied labs. So even at David's lab, it was more theoretical, which is like, how do we, get good performance on this data? But even then, my very first research project in undergrad was we deployed a model like this that predicted certain diseases. It performed well in the lab. We deployed it. It performed terribly. So my very first research project was, first, can we at least tell when the model is going to not perform well? And then the second step is like, can we correct that performance somehow? And so those kind of questions were already top of mind, I'd say, even when I was in research and being explored. And Andrew's lab was even more applied. We were mostly working with Stanford medicine to figure out, applied ML, like how do we, try to do that. Even then, starting my first machine learning engineering job, I was like, oh, wow, I don't know, I don't have answers to all these questions. Like, I guess I'm learning, yeah. And last point there is also the new frameworks, like Docker, Kubernetes, like all of the, DevOps stuff. And I was like, oh, wow, so you need to, already to be a machine learning engineer, you need to know math, stats, whatever, like, which is good to know. You need to be a good software engineer. You need to know your ML. And then I was like, oh, on top of that, now I need to know like how to deploy stuff. Like, yeah, I think it's less of a concern at bigger companies, but at a startup, it is really a lot to figure out how to make like machine learning work.
And so when you talk about these kind of steps in the pipeline, right? Like you said, you have to have these checks in between that in order to make these robust deployments, I would say, or productions. In software engineering, I have seen over the time software development has definitely gone mature, and they have these steps very well into place. So they have a better understanding of whatever things are to be done, and hence you can expect a very straight pipeline unless something of a big anomaly comes in. Do you think in terms of machine learning pipelines of production of any kind of applications, that for example Snorkel, do you see that pipeline in general, I'm not talking about Snorkel, do you see in the industry such kind of pipelines have been discovered, or are they still into process, or are you still discovering, hey, we need to put a check over there because this is something that none of us saw but definitely has to be a part of the pipeline? So is it into process, or do you see a major lacking that people need to have into place for reliable I would say machine learning designs? Now people talk about software design, I would say machine learning design. I don't know if that makes sense. Yeah.
No, that makes sense. You're right. Like software engineering, you have like CI/CD pipelines, you have very efficient testing and deployment setups. I think machine learning poses its own unique challenges, which is like, your data set, like the data could be changing, or it's like, which model did I use? So I think there's like machine learning specific challenges that exist. I do think that people have started thinking about it a lot over the last many years. And that's why you see like a lot of ML infra companies coming out. And especially like even monitoring specific. So that just when I worked at AI Fund more in VC, it's like ML infra is like a huge thing. Everybody's excited about. There's a lot of companies coming out. I don't know which ones are going to work yet because I don't think there's been a huge amount of adoption of any of these companies. Like I actually did a survey once I asked my friends who'd started startups all the way to bigger companies, and they were all building their own tooling. And I was like, well, who's buying all of these, ML infra startups? I don't know. So I think the thing there is like people are definitely thinking about it, and people have developed their own sort of workarounds around it. But I do think that there's no real standardization yet. Like even if you were to learn a lot about like ML ops is like, I guess the tool, like the word that people have been using. There aren't that many textbooks or courses or even like knowledge sharing yet. It has started for sure, but I think because of the lack of standardization, it's not very common knowledge, and people are still trying to share best practices and what's working. But definitely excited to see what comes out of this. And something I'm really excited to learn as well. But really quickly speaking to Snorkel, like we do have like, the software engineering checks for our code. We also do tests like, is the model performance the same as was expected, when it was run at a previous time on the same data set, or something off? Is the data that's coming in like different from the one that the model was trained on, things like that, and like continuous checking of the model. But I still think we are very early in terms of like figuring out the ML ops tooling and what that looks like.
And do you think a part of that particular problem could be the case that in itself the models vary, right? Like you don't have the best model for every application. If you see models, how they are deployed and how the priorities work in terms of starting with raw input to the predictions for standard computer vision task versus how the same algorithms to be used for medical data sets, they vary on a very different scales. I mean, people have been, for example, UNet. If you see, there are so many versions of UNet. It was recently like almost 6 months back that I figured out UNet was a part of my particular pipeline that I was trying to build, and I was doing my research, and it took me around 3 weeks to just at least list down how many versions of UNet for the very same task people have implemented. So I think, do you think that could be a reason? Like we don't have a stability in terms of models, we would say, and that is maybe causing the issues. We don't have a very standard pipeline for ML ops.
I do think the model could be part of it, where it's like, are you using the same model you were doing before? What tweaks are you making? Um, I think if we're trying to break it down into like data model and then like monitoring, I guess, like you train your model once and then in research, that's kind of it. Whereas when you put it into production, like you do have to monitor, like, is my data changing? Is my model going to be reliable? Things like that. So I think there's like the unpredictability of how the model is going to act that adds complexity, where it's like software, you run it again, it does the same thing, like what the failure modes are for the model. I think the only way so far has been to test it enough on different data sets and expect the same performance, kind of. So I think there's the additional complexity there. In terms of models, so you mentioned that people were using different models for different like for the same task. I'm not sure if what you're talking about is like reproducibility and like that problem in machine learning research, where it's like people implement something and you're like, I don't know if I can reproduce it. I guess like that adds another complexity. But even with the same model, I'd say like if you're keeping the model the same, the MLOps pipeline, it's like, well, what does that look like? And
Hmm.
I think
Yeah.
there's additional complexity there. Yeah.
Right, right. All right. So I just want to mix few topics up and maybe switch, and maybe we'll come back to the MLOps thing too. But you did work at with Andrew at AI Fund, and it's a pretty diverse role that I had a hard time to figure out what exactly you worked on and what questions I should be asking. But it definitely seemed interesting to me personally because I really like the idea of I correct me if I'm wrong, but you had something to do with at least one part of that was product design. You had to work with design of products and maybe also help companies start from a scratch, the 0 to 1 phase of what startups look like. So can you talk to more about that particular role? It seems really intriguing to me, at least. Can you talk more
Yeah.
about that?
No, definitely. Yeah, it was definitely a very interesting role that took many directions. I could talk about how it sort of started. So I'd already worked with Andrew for a couple of years till that point. And he'd started AI Fund around the same time, which was a venture studio at that point, which is they would try to start companies from scratch internally. And then once they got to a certain point, hire a CEO to sort of run that company and take it forward. And then AI Fund would be a co-founder. So that was the general genesis of the company. And I was working at Landing around that time. And I was very interested in product because I was like, a bit of the reliability question of models is can be sort of mitigated, I guess, or handled by good product designs, which is if a model is not sure, maybe try to bring a human into the mixture instead of just like making a prediction. So it's like there were a lot of questions about like how to design an actual product to maybe sort of get mitigate some of the model shortcomings, which I thought was super fascinating. And so I was really interested in product. Thought I was a decent ML engineer at that point. I was like, hey, can I, work at AI Fund to help support some companies because they're very early stage. I could do both. And I'm very, very thankful for Andrew for taking a chance on me and sort of hiring me into this like super undefined role, and which is why it's like really hard to explain. The product associate title is kind of like I just gave myself, and they were like, okay, sounds good. So it was this super undefined role, which is like you help us kind of start companies internally. And so when I first joined, because I'd been a TA for 230, they wanted someone to help out with Fourth Brain, which is now one of the portfolio companies, which is like they do machine learning training programs. So instead of like Coursera and the courses online, which are very lightweight and, you know, sort of people do it on their own, can we do something that's more involved boot camp with career placement, things like that. So I started working on that, did literally everything as like with help from a partner at the fund, Shah, who was also very great to work with. And basically and with Andrew's support, obviously Andrew was very into education and, you know, democratizing AI and stuff like that. So really did everything from like talking to customers, being like, where's the gap in the current ML teaching space? Like, what are people looking for? What do they still want to learn? What can we provide? Who should we target? Who should we sell to? What should the pricing be? What does the financial model look like? Like, how is this going to grow? What does the curriculum look like? Does that resonate with people? Is that something they'd want to pay for, and how much? And then what does the marketing look like? How do we hire the first cohort? So really a very diverse set of experiences, which again, could not have planned for really. I don't know what I was getting into. And that was really great learning experience. We later hired a CEO into the company, Salva, who's amazing. And now Fourth Brain is still, you know, running as like a company that does machine learning training programs and places machine learning engineers. And then I moved on to a different company because I was more interested in product, whereas this was more of a services company. So I worked at a different company called Credo, and it's run by Navrina, who's amazing. And the company is more around responsible AI. So it was, how do we, you know, as a third, sorry, it might have evolved into something else after, but it started off as like, how can we test like fairness of machine learning systems as like a third party auditing. And really, that was the first time I got to think about like ethics in AI and things that we should be thinking of as people who are deploying models that make predictions that affect people's lives. So really a cool, like a awakening there, but it was really cool to work on. Did more machine learning engineering work there. Also a bit of product work to be like, how do we build this back into the platform? Like, you know, a product for Credo. And then the fund strategy just changed because they hired a new general partner, and they said that, you know, they wanted to do more external investing. At this point, we'd mostly been starting companies, which starting one company is hard. Like doing that repeatably for a very long time is really hard, and the fund raised a lot of money. So for multiple reasons, and there is a lot of AI talent out there. Andrew's really great at, you know, as a brand also. So they decided to move to external investing for multiple reasons. And with that, they were like, do you want to try venture now? And so for 6 months last year, I was also doing VC for a bit. And that is why it's like really hard to describe my role. And then that's why I was like product associate, because I did product and machine learning engineering and also VC. But really, I think it was a really great learning experience to see all of these different aspects of a machine learning engineering role and get exposure to that. And truly grateful for Andrew and all the partners there for being such good managers and like really helping me learn. So that was like my role there, if that helps.
Right. Yeah. That's really interesting. I mean, you covered a breadth of a lot of roles that typically how machine learning engineer would normally target after his or her graduation. But I want to dig more onto those things. Is like when you say you are wearing these multiple hats. Typically, I have seen like I have in the past I have interviewed few product managers, and one thing that I've realized is although it seems very intuitive how to design a product, it's one of the hardest jobs. I mean, definitely technical skills are at par over there. It is definitely a different domain to be tackled with. So did you like, was it much more of a application oriented learning on your side, or did you particularly plan something that, hey, okay, I don't have the skills, let me sit down, maybe take a course, or maybe do I learn, or maybe just Google out? How did you build your competence for those kind of roles? Or was it something, how the proverb says, right, like the work will teach me how to do it, like, or was it the combination of all of those things?
Yeah, no, definitely felt like I should have done some like formal education around this. So I took like one product management class at Stanford, which was kind of helpful. And then I did like, in addition to AI, HCI, which is like human computer interaction. So got to think a little bit and take classes around. And Stanford's really good at this, like how do we design UX? How do we prototype stuff? How do we test that out? How do we start companies? But I would say I still felt very much like, oh wow, I have to, learn on the job. Like, what am I doing? I have no idea. And I have a lot of books too about like machine learning products, startups. But really, I think the thing that helped was just learning by doing and having mentors. Like when I was at AI Fund, like having Andrew and Sean and Perry, who are the partners there, like guiding me through it a bit, or sort of kind of just learning on the job, quite honestly. But that is not to say that didn't feel like I should have, or like I should know the right way. But it was more like on the job teaching and then reaching out to mentors, like even let's say Navrina, and being like, how do I do this one thing? Like, what does a PRD look like? Things like that. The good thing about like when I worked at AI Fund, it was so early stage. Like there didn't need to be a process, and I didn't have to do the right thing. I just had to like get to an outcome. And so it didn't matter that I didn't know how to write like the PRD the right way that someone might want to at like Google or Microsoft or Twitter or whatever big company. It's just, can you get the product shipped? Can you define an MVP well? Like, do you have those kind of things? So I think a bit of product management is also just like intuitive. I don't know, where it's like, what is the minimum thing we can ship to make user, like, what is the goal of this and things like that.
Yeah. Yeah. I guess this reminds me of a quote. One of my co-advisors said to me that it's learning on the fly is the best way of learning, because if you go by textbooks, you will take forever to get your degree or whatever you're targeting. So I guess,
Yeah.
yeah, that makes sense. Yeah.
I also think it's like just reaching out to people who you admire in that role and sort of asking them like, what would you do either in that specific situation or, just catch up with the field in general. I definitely did that a lot more when I had to take on a VC role, because I was like, I don't know the first thing about being an investor. So I reached out to, and that's what's so great about Silicon Valley. Like all the people I reached out to responded and took the call with me and walked me through, their first investment, how they were as associates, things like that. So I think just reaching out to people, and most people are very open to, if you frame it the right way and make specific asks like cold email reach out, also works effectively.
Right. Right. So if I were to stitch a few of the points we had the conversation so far, is like, you have been working at Snorkel, which is a very open source project kind of company that is trying to build itself, and you have been dabbling around, like you said, on the product side, VC side, and also have seen a few companies where you were working with AI fund and trying to start from scratch. One question that me as an academic researcher that normally see is, we see these papers coming in every now and then, every week. I mean, if you pull up a central repository of papers who would be publishing, there are tremendous amount, and they are good papers. I mean, most of them are beating state of the art every month now. If you see in language models, they have these leaderboards and you see marvelous work being done. But when it comes to production, when we see like, okay, when we read these papers, we feel like, okay, this is going to be the next big thing, Google is going to change because this is a great research. But we don't see that productionized very well enough, or at least it takes 5 or 6 years. Where do you think companies typically fail at productionizing these things? Is it eventually a slow process, or is there a something failure point in itself when we take these models from papers to productionizing it so that users can interact? In your experience, do you see any kind of pitfalls over there for the standard pipeline?
Yeah, no, definitely. There's so many papers coming out, really hard to keep up. I think the main reason most of them are not productionized is really like, do companies see enough value in deploying them? Especially a lot of models right now are getting very large. And so it's like the cost of training, maybe fine tuning, deploying, the latency requirements. So it really goes to like, is the model really going to be beneficial to my task over a very simple model that I can understand what it's doing, that I can sort of deploy very easily, that I can monitor very easily. So I think in a lot of cases, and this was also a learning back to like the, what did you learn when you were a machine learning engineer role? I think in images and like, when we were at landing, we did use like state-of-the-art models like to figure out what was happening. But in a lot of cases, and I did a lot of deep learning stuff, but in a lot of cases, like if you're especially starting from scratch for a startup, the simplest thing, you just want to try out the simplest thing that works, and you use something off the shelf that maybe somebody else has already implemented, and then you try to use that because you've heard of it and it performs reasonably well. And a lot of thought is actually more around like, what does the product experience look like, getting your customers, things like that, at least in the beginning. And even at Snorkel, it's like we always try to go with the simplest thing first, just because it's like easier to manage, easier to implement, easier to deploy, all of those things. And with these state-of-the-art models, it's like, unless it's something that's really going to give you a huge jump in performance, which a lot of these just have like minor jumps, right? So really it's like, yeah, how much benefit are you going to get from this? And if the benefit is large enough, like I think I don't know the exact numbers on this, but I think it's like BERT, because it was so successful, Google was able to implement it and productionize it across all of their systems very fast. Like I think it was like a year or so. So I think if the value prop is strong enough, then companies do it very fast. But in general, I feel like you do want to be like thinking more about the problem and what's going to solve it rather than like more state of the art stuff. One caveat there is like at Snorkel, we do keep track of like papers and stuff that's going to help us. So again, it goes back to value prop. Like we're thinking about like weak supervision. How can we auto suggest labeling functions and things like that, which is quite state of the art. And we are thinking of productionizing it just because we see the value prop being large. But in terms of like the latest transformer model, which is like slightly better than BERT, it's like, is that really going to dramatically help? And is it harder to maintain?
Right, right, right. Yeah, that makes sense. Yeah, it's quite on the trade-off point where versus how the architecture is going to suit the platform in itself. For example, Google in itself has a different kind of platform and the product they are building. So definitely a very stacked up versions. Like we see a lot of stacked up versions in medical imaging sector, right? Like you put all these things together from the computer science research, and they build a very complex structure, but that just adds up. Like you said, it has to be a simple enough. I mean, definitely not simple in terms of deep learning. They are complex in itself, but it has to be simple enough so that people can productionize it. If I just merge every kind of encoder decoder versus FCN and everything into one place, they don't make sense, even though they might be doing specifically well on a good data set. So yeah,
That
that
makes
makes
sense.
sense.
Also, another thing is I think Hugging Face has been really great in terms of like, implementing the latest and greatest. And I think that has helped people incorporate a lot of the latest and greatest like stuff into their own platforms. Because really, like when you're trying to work at a company, like you don't want to implement a paper from scratch and like try to make it work on your system. That's a huge time sink, depending on what your priorities are. Like if it is a huge jump, maybe you'll do it. But the fact that Hugging Face just does it and you can just change the model and then call it, I think is really helping with like productionizing or like really a lot of these things being used practically.
Mhm. And talking about productionizing, so in terms of advices, where would you say for people? I mean, there has been a clear path, right? If you want to be a researcher, the best way is to do like you said, getting to working with a professor or doing a PhD. I mean, not the best way, but doing a PhD would be along the lines of getting into the depth of a research. You can definitely say you are an expert, but ML ops is something not a lot of people know. There are no standard rule books that people say. It's like you said, if you struggle a lot of nightmares and a lot of bored nights, that you learn that okay, this is how the pipelines are. In terms of your experience, how would you say people should, if I'm really interested into the productionizing version of ML models, I don't want to research, but if you give me a model, I want to really make a reliable product out of it. How should I start my journey versus what are the pitfalls that I should avoid? Like people say this, but don't do this. Certain kind of. Do you have any such kind of advices?
Yeah, no, to be honest, I am also on the learning journey of trying to figure out like what ML ops looks like and what ML infra should look like in the learning there. That's I think one of the core reasons also why I joined Snorkel, because I was like, what better place to learn how to build a machine learning platform than a company that sells machine learning platforms? And I don't think it's like a very solved, like this is the thing you should be doing, and here's like the templatized version of like how you should be deploying stuff. And so it goes back to what I said, which is like it's still something that we're working on standardizing as an industry, and a lot of people are interested in this. Like I spoke to, I think, hundreds of people while I was trying to do interviews for Fourth Brain, and like, what are you interested in? And the number one answer was learning how to productionize machine learning. And this is from people who like already work as machine learning engineers at Netflix, at Apple, and they're just like, I'm very curious to see what other people are doing, what other people are learning. So overall, everyone's interested. I still think, I mean, I bought 4 books, I think, last year itself on like ML ops and like productionizing ML. I have yet to read them, but and there's a bunch of blogs I follow, and like there's a bunch of talks that people do. So overall, I think we're still in the learning what works. And then if you're at a company, you're very acutely aware of things you need to do, and that really is the best way to learn.
And And I think it would be really ironic. It's like learning MLOps from books would be like, even the book would say, just get your hands dirty, don't really have it. It's much more of a hands-on. So yeah, yeah. But
Basically,
please,
yeah, that
yeah.
that was like the first page. They're like, just go do your work. And then before...
Yeah,
Yeah, no,
yeah.
kidding.
But
But
please continue. Yeah,
yeah,
yeah, yeah.
it really is the best way to learn. I think another way is just like, I think a lot of companies have really good engineering blogs about like how they deployed their ML systems and things they had to be aware of. But honestly, I think just like a lot of people think they maybe need to know that before getting into machine learning, especially if they're self-taught. It's like, really, even if you went to grad school and worked in a research lab in machine learning, like people don't know this until they actually start working. And so really, I would just start working somewhere and then learn that way. And then there are a lot of resources out there, but there's no real consensus. So know that, whatever you're reading could change and it's not really standard yet, a lot of it.
Right, right, right. So let me put you in a weird spot right now and maybe ask you a question. Which part do you enjoy the most? Is it academic research, working at David's lab, Andrew's lab, or working at Microsoft even, and versus on a very hands-on journey, which is Snorkel, which is, I mean, Microsoft would be much more of a mature pipeline-based work over there. You would have pipelines over there. When itself, Snorkel, it's kind of a building up company. Which work environment versus work assignment do you enjoy the most?
Yeah, I'd say I really enjoy, and this is a lot of soul searching I had to do when like leaving AI fund, because I was like, what do I do next? Do I go work in product? Do I go work as a machine learning engineer? Like, I'm so confused. And so I do think I realized that I really like working at startups. So that's one thing in terms of like stage of company. I really like working at something early because then you get more flexibility in what your role is. Like right now, I do a bit of product work, I do a bit of machine learning engineer work, and the amount to learn at a startup is a lot. And so Snorkel, especially, really loving it here over the last 2.5 months. I really liked working at AI Fund on early stage startups too. So in general, I think anywhere where I'm just learning a lot, I like. And the general theme I like is how do we make AI practical, and how do we just like build and ship AI products? So if that involves a bit of like, reading research papers, trying to figure out how do we make something like the current problem that I'm working on practical, happy to do that as long as it has like a very real world implication. And then similarly, very interested in like doing product and engineering to really figure out like what can we do. I still think we're so early in like ML, in terms of both like where we are in terms of research and where we are in terms of like productionizing and seeing the value. There are really lots of interesting problems everywhere, to be like, how is this going to play out? And I think the more skills that I can acquire in doing that, either in product engineering, the better. So that's sort of the framework I've been using, like more skill based for making AI practical. What can I do?
Yeah, 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 that definitely makes sense. And this was recently, and this was even a learning curve for me because I didn't, I always had that before I joined over my PhD. I always thought it's always the big companies who are working on these big models, right? So if I want to learn in the best sense, I should be joining a big company, even if it as an intern or as a full-time career. But even recently, when I was talking to these few peoples on Clubhouse, and when they mentioned what kind of things the challenges they're facing versus even as a PhD student, I'm working at a startup with my professor. The kind of learning curve, I mean, definitely it's no way a good life. I mean, definitely it makes your life hell for sure. But the kind of learning curve it provides, I can just imagine what you would be dealing with while working at Snorkel AI. So yeah, definitely kudos to that. I definitely second you on that. And yeah.
Yeah, definitely. And especially if you have like multifaceted interest in terms of like you like doing different things, like you're not just an engineer, not just a PM. Startups really offer you the flexibility. And really the working hard could be fun if you really enjoy working with your coworkers. Like I really enjoy working with my coworkers. So if I'm working late, which again, like you can work as late as you want, or there's like peaks and troughs like for a startup, and we're good with that, whatever. So
Yeah.
but I think just in like working with people you enjoy working with and working on a problem you find interesting is just rewarding as an experience.
Yeah.
So
Yeah, right, right. And one question I had, and this is kind of a very clickbaity question that I normally ask, is when you are dealing, like you said, you have dealt with people who are on the consumer aspect of machine learning, who might not be the best researcher, who might not have the best knowledge of machine learning model. And right now also, even at Snorkel, you're working on the production version. What is one underrated and overrated thing that they think about AI? Like I always see when, for example, when I'm dealing with, I mean, I'm sure hopefully none of the PIs of my grant are watching this, but they come from a medical background. They have had practice for 30, 40 years. They don't understand
Right.
the mathematics of machine learning. And when I show them the results, the way they investigate those results, I mean, no way, they are making good points, but that's not how machine learning produces, right? Like it talks, but it talks in a different language. In terms of dealing with different people, and I'm sure your work with Andrew at AI1 would have opened you up with a breadth of those kind of opportunities. What have you learned? What have you seen as one of the most underrated thing, which is like nobody's talking about, like we should talk about this, versus overrated is like please stop talking about this. This is not some magic wand that you have in your hand. Do you have any insights on that?
Okay.
Yeah.
I think an overrated aspect is I think people don't realize how unreliable machine learning models are in general. So it's like, let's say, like I worked on a paper that did chest X-ray prediction and like, you know, tried to predict if someone's gonna have a certain disease. And it's like, you like to get it into production is quite hard. So it's like, you know, something might work in a research environment, but we're not really close yet to actually deploying it and making it work. Like, I don't know if you saw like the clip results recently, like great work, but it's like they put an iPhone sticker on an Apple and then it classifies it as an iPhone simply because somebody wrote the text iPhone on an app, like on an Apple object. So I think just the reliability, and people just think that, you know, it generalizes to other things. So it's like just generalizability and reliability of machine learning models, where it's like, okay, we're not ready to deploy them yet because maybe we don't know how they're going to react to certain things, and that kind of stuff. Also, I think like last year, all everyone could talk about was GPT-3, which I have friends at OpenAI. I think it's a great company, and they've said this too. But I think it's like, especially, I think it's really cool, like the research results that they, or sorry, the results that they had, and just the effort in productionizing it. But I think people who are especially not technical got super excited, and they were like, "Is this AI?" You know,
Yeah.
and it's like, okay, well, it was just trained on a large amount of data, and there are very impressive qualities about it, like how it can learn from very few examples and things like that. But people were super excited about the part where it's like, oh wow, it's generating text like a human would. And it's like, I think that's exciting, but I think there were other more exciting parts about it that was not necessarily the part that people got super excited about. um yeah.
Yeah, that makes sense. I guess it's the surface level version that people create that really creates the bad version of AI, versus like people fearing AI versus people making wrong uh, conclusions about AI and how those clickbaity articles are being produced. I'm sure even the people who are writing those articles know that they are trying to create a clickbait rather than actually doing the actual true face transparent of the research. But yeah, like you said, I definitely like the whole research behind GPT-3, and I guess even this was recently in one of the, I don't know if he's a co-author or the main author, but he was talking in Clubhouse, and he has said in those papers and a lot of places that this is in no way we are targeting from a productionized perspective. We don't expect people to work, but this is just a step 101 for doing, like trying to just make push to a boundary and see if people can do it. So yeah, that what you said definitely makes sense. Yeah.
Yeah, I think so. And I think in general, I think people don't realize that we're really good now at, like, I think, well, I'll go with one underrated aspect and then generalize the overrated aspect. I really think an underrated aspect is how much the AI community and how much we've learned has grown, like really astronomically. Like 2012 is really when like AlexNet came out, this whole thing like really took off. And not that many years later, there has been so much progress in so many different fields. So I think just the level of like smart, dedicated people working on really cool problems and the progress we've been able to make really makes me really excited to be a part of the community. And everyone's really friendly and open with sharing their knowledge. So hugely underrated, I would say. Um, Back to the overrated aspect, I think we've gotten really good at, when we have a large amount of training data, how can we train a model that fits to that specific data and then does something? But I guess what people don't realize is we're not very good at detecting when something is different from that data. If we see something else, like how is the model going to react? And then also how to get the data in the first place, right? Like that's kind of where Snorkel comes in, and I'm
Yeah.
kind of excited about that. But I think people don't realize that only if you have a large amount of data, you can fit to it and you can fit to exactly that, but maybe you're not really generalizing that well. And I think that is the more overrated aspect of where people think AI is, where we actually are.
Yeah, definitely. I would just like to add few pointers, because even before I had thought of that particular question, I had a very similar thing that you just said. The most underrated thing that I think is, like you said, it has expanded it a lot. I mean, in terms of results and in terms of doing its job, that what people are expecting, it has done a great job. The underrated aspect is not a lot of people are trying interdisciplinary things. For example, I personally feel very nice. I mean, it's not applauded in the industry a lot, but the application of machine learning for medical sciences, and we are trying to see at least few of the, for example, AlphaFold. I was the crazy person who went out of bed and clapped that, like, this something, at least there is one scope for
Very cool.
discovery. I mean, I was just looking for pointers who might say that machine learning can help discover something in the medical research, and that's like one of the most underrated aspects of machine learning or deep learning in general. And yeah, overrated is something, like you said, people just don't understand how, like, that definitely has a place for transition. You can translate how you are dealing with data, but it has to be done very carefully. And I guess that's, if you see most of the papers in medical imaging, at least the ones I know, they always have big sections of data pre-processing, data loading, and the model is just like, the architecture is just maybe one small paragraph in one column format. So because they know what AlexNet looks like. So yeah, that makes sense. That is one overrated aspect. They just assume that I would be just able to just pull up that model, put it on top, and it would be a cherry on a cake. It doesn't work like that. So yeah, that makes sense. No. And yeah, just to end, I just have one open question over here, and feel free to take it anywhere that you want. Is, what is one thing in terms of research topics? It might not be relevant to what you're working at Snorkel, or it could not be that you have ever worked on, but what is one research topic that you have been following or learning more about, that you are really optimistic or keeping an eye out, that, hey, what happened to that particular topic? What is that particular person working on? What is one thing that you're optimistic that, okay, in 2 years, I see, I hope this really turns out well, or this is really interesting?
Yeah, I'll kind of answer that question and then caveat it with like there are topics that I think are really interesting, but I have not done a good job of following them, so I will list them out. But really, after you asked me that question, I was like, wow, I should be doing more. You know, you get so caught up in like the day to day and things like that. So yeah, but the topics that I think generally are very interesting are, again, if you go back to this framework of we're really good at, if you have a lot of training data, we can train a model and perform well on that data. Generally, like let's say image, speech kind of now, but like natural language processing. But really, like, how do you get to that labeled training data, or can you do with less data, or can you do with just like no labels at all? So I think just the theme of like moving from supervised to weakly supervised, semi-supervised, unsupervised, which seems a lot farther out. But just in general, like things around data and how can we make models like more smarter, or maybe encode stuff better rather than just like dump feeding it a bunch of data that takes a lot of time and is a huge labeling burden. So in general, that area. And then another theme that has been recurring throughout is, which I started my machine learning journey with, which is, can we even detect like when a model's not going to do well, and can we retrain it, or you know, try to mitigate that difference in the distribution of the data, or things that are going wrong. So I think just those two in general are things that I'm very interested in, and we'll have to do a better job of keeping up to date with. So unfortunately, haven't done that, but just in general, interesting topics. And I do think that one thing that just caught my attention since I was working at Credo, which is like, how are we actually building these systems, and what is the data set, like what are the biases in the data set maybe, and how do we even know, like it goes back to like, do we know what this model is going to do, but it's like, is this model going to have some biases from the data that we don't know about, and it's going to make some harmful decisions because of the biases in the data. So I think just being more mindful of that as like the people who are in charge of, you know, building these data sets and models, I think has been a huge awakening for me, at least. And as the data sets get larger, quite honestly, it gets really hard to, you know, monitor these data sets, try to figure out what's going in. So ever more of a issue or thing to be mindful of, I think.
I don't know if this is a weird coincidence of resonance, but I definitely, again, that is one thing that really interests me even, and that is one thing I don't know if I fear a lot doing my research over here and doing my thesis on interpretability, that I'm trying to deviate more along the from the standard research of computer science, but my work over here definitely got inspired, and the reason for me to do a serious research was on the interpretability aspect, like you said, understanding these biases. Like, well, we have these great models doing great job, good work, but definitely on the interpretability and reliability aspect, how do I make sure, because if I build the model and if somebody wants to use it, how do I answer, like when the medical expert asks me, how well is this, you built a great model, well, the AUC curves look nice, but should I go ahead and use it in the lab settings? That is one thing that really excites me. So I don't know. I'm a bit feared because it's not a core computer science research problem, but that really motivates me well. So yeah, it's a
Yeah.
definitely interesting topic. Yeah.
I definitely think, yeah, I generally tend to separate a bit like interpretability and then sort of, I guess it ties into like, can you, sort of reliability, and it's a part of it. But interpretability is also very important. Like, for example, I didn't personally work on this, but I know a group that did. For example, it's really important because you might artificially get good performance, and it's only because of artifacts in your data. So for example, there was a group that was working with like sonograms, or I think it's like ultrasound, like gynecologists, like the output that comes out of that, and trying to predict like something. And then they found out that from doing like grad camps or other interpretability stuff, that it was just picking up on like text on the screen, or like there were data set artifacts that made it very obvious, or like maybe a clinician had already added like pluses in the data. And it's like, one, it's really important to look at your data just in general. But second of all, I think interpretability just lets you be like, is it picking up on just random things in the data that have nothing to do with what you're actually trying to predict? And yeah, you just look at the number and you're like, oh wow, what a great model. And it's like, well, it's not actually good because it's not doing anything useful.
Yeah, definitely. And again, this was, I was just reading this thing yesterday. There was this paper who is a, I don't know, I don't remember the name of the researcher, but there is a GAM model. I forgot again. It's something additive models. I forgot what the G stands for. But one of the outcomes of that particular method, what it figured out, that in textual data, when we are using clinical data, there was a good accuracy. It was a 78% accuracy for the task it was doing. But in interpretability method, what they figured out was there was a particular spike that was actually causing it to have good uh, results based on the mean value of the features. And the way mean value was calculated, because they were imputing the data, missing data, like we have missing data right in the clinical data, and they
Right.
were imputing it using the mean values, and that was actually causing the model to have a great accuracy. And I was like so shocked that, okay, now I have much more pivot point to be a person who actually tries to work on interpretability. So yeah, it resonates well over there too. So yeah. But apart from, yeah, thanks a lot. This was definitely a fun interview, and one of the few things that I really liked about your profile is you have uh, one of the few people who have such kind of diverse backgrounds of working at places, like being from VC to product manager, associate, research labs, Microsoft intern, and now it's Snorkel AI on DevOps, MLOps, sorry. So yeah, it was really fun. I hope people who are listening to this particular podcast also finds useful, and I'll leave a link to your social media channel so that people can reach out to you if I have any specific questions or suggestions, or if they want to just have a quick chat with you. So I hope they find it useful. And once again, thanks for being here.
Yeah, no, thank you for having me. This was a really great, fun interview. And actually, some questions made me introspect and realize that I should be, focusing on the problems that I really care about as well. So overall, a really fun experience. And yes, I'll leave my social media links. Please feel free to reach out. Happy to chat anytime.
All right.